Okay, so this is an Electronics 101 video, and the subject is resistors. In the circuit, these are used to decrease the voltage and or current depending on how they're put in. They are really just very thin wire running through, and then there's some extra wire running around it, so it just basically, well, not around it, it's actually part of it, so it has to go through that giant coil of wire, and the wires add their own resistance. So they all have different values, which you can see also have different color codes on them. And this one is 100 ohms, which is how you measure the value of resistance. And it's 100 ohms. So the first one is a brown, which is a 1. The next digit is a black, which is a 0. And then the third digit tells you how many more zeros after that. So brown, black, black, 1 0, and then no more zeros after. So 100. This one is 1,000, so it'll have 1 0 and then 2 more zeros. 5.1 thousand, 5 1, and then 3 zeros, so on and so forth. And then you have ones that are variable resistor, so you can actually change it from practically 0 all the way up to 500,000 ohms with this one. And we have other variable resistors, so that wherever you slide this, the resistance between these paths will change. So this one will have less resistance on this side, more resistance on this side, vice versa. I think that's a 50,000 ohm, and that's a 10,000 ohm. So let's verify that these are correct, and we'll hook up a multimeter across that resistor, and we should read around 100. Yeah, 102. That's within that, what, 5-10% from 100. The more expensive you get, the more efficient and refined they are, so they will read pretty much spot on. But the cheaper versions, like I say, vary between 5 and 10%. Now these are typically used, like I said, in circuits to control the voltage. Like, say you've got your power source, and your work is done, in this case, by an LED, and we want to make sure that there's not enough voltage going through here to burn out that LED and kill it. So we protect it by slowing down the voltage and current. Another way to use them is in what's called a voltage divider. So here we have the power source, which is just 2 AA's, so it's about 3 volts. You could also use alternative power sources like solar panels, rechargeable batteries, wind power, water power, stuff like that. Just make sure your circuit is protected from the elements. So we have up to 3 volts coming out of this, and then that 3 volts will have to be used throughout that circuit, because if it's not, those batteries will get too hot. So let's verify that the reading coming out of the batteries, positive here, negative there. Oh, let me switch it to direct current instead of measuring ohms. Okay. So 2.2 volts. They're not brand new batteries, so that's acceptable. Now, we can verify by measuring across the load, which is both these resistors, should be using our 2.2. But since there's 2 of them, and you'll notice they're equal value here, so it's easy math, we just cut that in half. So we should get around 1.1. So that way, you'd use that voltage divider to say you only, while something down here would use the whole 2.2 volts, in this part of the circuit, another branch parallel would be using only half of that, so the 1.1.